Welcome back to the second part of the Box2D tutorial, and in this video we're going to take a look at a few features of the Box2D which might be important later on, nothing too specific. So in the fixture we're going to take a look what these three values stands for: the density, the restitution and the friction. So let's try to change them. Here in the addRect function, after we set the density, let's try to change, for example, the friction. Okay, so fixture def dot friction and make it equal, without t actually, and make it equal to, I don't know, 0.9, and let's see what that's going to result. So here I am at the terminal, and I can compile it and run it, and let's see what does it resulted. It may be a little bit hard to see because this platform is vertical, actually it's horizontal. So, but it make these little cubes like they were from something like rubber, so they do not slide on the left or the right. So if I make some power like that, as you can see, they do not slide because they have very big friction. But if I change it to very small, like 0.01, that's a really small, actually you can change it to 0 if you want to. Actually, let me make it 0 just to show you that you can do that. And now if I compile and run it, and if I drop a few cubes here, as you can see, they are like eyes or something. They really easily slide or to the left or to the right. Okay, so that was the friction, basically how well can they slide. And let's see the other, which is the restitution. So fixture def dot restitution, and make it equal to, I don't know, make it equal to 0.8. Okay, and try to run it, so let's see what that resulted. Okay, now drop, and as you can see, it's like a ball, it's bouncy, can easily bounce, and now they can very easily slide too. So they slide all this little ground which I have put here. Okay, that was it. So usually the friction is a higher value, like 0.9 for example, to make it from rubber, and the rubber is very easily it's very bouncy, so it will be maybe a little bit more realistic in this way. As you can see, they bounce there. Right, so this was the free value, and by the way I didn't change the density, so if I change the density, that will just pretty much cause that the mass will be 10 times of that. I think it will be a little bit hard to see. It's easier to see if you have a material with very high density and a material with low density. In that case, if they have the same speed, then the material with the high density will obviously win, basically, because it has a higher density, it has higher mass. So it will pretty much, if they collide, then it will hardly lose its speed, while the material with lower density, like, I don't know, something light, it will pretty much just change its speed very hardly when they collide. Right. So that was about this free variable, and let me make it back, and let's see about the forces which we can apply. By the way, watching the last tutorial, I realized that I have forgotten to return with this body. So let's just return with the body. It doesn't affect anything because I so far didn't use anything, this return value, but if I would use this return value without returning, that probably will be segmentation error or something. Okay, so let's, for example, make a simple square right here in the init. So right here I add another square, add rect, and this rectangle will have, actually we will save its pointer to the body, so b2 body, and call it, I don't know, myRect. Okay, and make the myRect equal to this, myRect equal to this addRect, and add the rect, I don't know, the position should be, make it like 100 on the x, on the y 200, and the width and the height, make it 50 by 50, and it will be a dynamic object, so it will react to gravity and everything else, so I can just leave the default true parameter as the last. Okay, so now if I compile it and run it, as you can see, we have a square right here. So now I want to show you how you can apply forces, impulses and torques to this little rectangle. It's actually quite simple. Here in the display function, although it's not really display, it's rather an update kind of thing, but I just do it here in the display. Alright, so I will get a vector which pointing to the current cursor position. So I can get the current cursor position if you are using SDL. You can get the current cursor position on your window by using a function called SDL get mouse state, and it will return with a uint 8, I believe so. Is it? No, I think it's just I think it's an integer. So integer and xy, and you have to give the address x and y to here, x and address of y. Right, now we have a xy coordinate. So I want to get a vector which pointing to the cursor. So let me make a b2 vec2 object, and I just call it, I don't know, direction. And this direction, actually call it mouse. And this mouse will get the xy coordinate. So now I have a vector which has the xy coordinate. Now if I want to get a vector which pointing to here from somewhere else, then I just subtract it from this mouse. So let me immediately do that. We get the position of this rectangle. To get the position of this rectangle, I just use the myrect, which is the body, which I have here, myrect, and get the center of this. So to get the center of this, I'm pretty sure we have to use the function get word center. Although I can check here in the source code to see if I am correct. Get word center. Yep, right here. Get the center of the mesh. So it's basically just the center of the cube. Actually, it's a rectangle because we are working in 2D. Okay, and then this is a vector, and I subtract the mouse minus equal this. So now I get a vector which pointing to the mouse coordinate. So this will be basically a vector which will be our force. And let's apply the force right here. So myrect, and I apply a force, and right here apply to force, or apply force to center. Both of these will work. The apply force to center will basically the same as apply force, except the second parameter is the get word center automatically. So apply force, and this apply force will waiting for this mouse. So mouse. And the second is basically the where do you want to apply this force on the body, because of course you can apply it right here in this corner, or somewhere here, basically anywhere, but most likely you want to apply it to the center. So in this way it will not rotate when you are moving the cube. Also you can apply it to outside, so even you can apply it to here even though it's not part of this cube. Or rectangle. By the way, I just realized that we should multiply this get word center to meter to pixel. So multiply meter to pixel, because this get word center is in meters as everything in Box2D. So we should convert it to pixels. Right, so I apply the force, which is the mouse, and the second parameter is where do you want to apply this force on the where you want to apply this force, which is just the center for now. So basically it will not rotate when I apply the force. And I'm pretty sure we are finished. So now if I can compile it, and no, I cannot compile it because the multiplication is not made in the way I thought it did. So we have to change the order, because if I just get this to here, it's right that first you have to put the floating point number and then the vector. So there is no overloaded operator in the class, just global overloaded operator. So where were we? Yeah, here we should put the multiplication sign and delete the minus sign and put a P. Right, okay, now if I can compile it and run it, oops, as you can see, it will try to follow the mouse. It's basically the center of its gravity. If I move it to somewhere, it always tries to follow it. Incredible. Now the force is a continuous force, so it's like pushing something. While there is something called impulse in here, so if I go here in the body, you can also find apply linear impulse right here, which is almost like a force, except it's like for just a moment. So like if you jump to something or hit something, it's not like continuously push something. That is the difference. So let's try to apply a linear impulse as well. I only want to apply the impulse whenever one key is pressed. So for example, the space key is pressed, then I want to apply this impulse. So I make another case statement right here when I determine which key was pressed for the space key. and if the space key was pressed, then I use the myrect apply linear impulse function, which again waits for the same two parameter which we had right here. So it's waiting for the center where you want it, and it also waits for the force. Let me just delete for this force now so we can more easily see the result of the impulse. And here let me just make b2 vec2, and this will pointing to the 0 in the x direction, and for example make 50 on the y. I'm not sure about the values, what would be a good value. So 50 is, let's make it 20 and see what it's going to result. And again I get the center because I want to apply it to the center. So get word center. Right. We are going to apply an impulse whenever we press the space key. And so let's test this out. So now it's done, and when I press the space, nothing is happening, and that's probably because it's not enough. Let's make it 100 and see what's going to happen. Probably the gravity was too big. Still nothing. 1000, guess. Oh, the direction was the wrong direction. We want it to go up. I used another coordinate system. We start from here upwards like the OpenGL, but we use a version like in the SDL. So now if I compile and run it, and as you can see, whenever I press the space, it's basically jumping. That's the perfect way to do jumping in your game, by applying a linear impulse upward. So now with 40, as you can see, it's like jumping. Okay, and you can also not apply it to the center, but for example, let's apply it to a vector, so b2 vec2, and for example, let's apply it to the left top corner. To apply it to the left top corner, we have to calculate the left top corner. We know that our rectangle is 50. So here, where I made this rectangle right here, I made it 50 width, as you can see. So now, if that pretty much means that the left top corner is minus 25, minus 25, minus 25, minus 25. But we need to convert it to meters. So multiply by pixel to meters. Multiplied by pixel to meters. Perfect. And now if everything goes correctly, then we see that the cube is actually not just jumping but rotating like crazy. So now if I compile it, and now as you can see, it's rotating like crazy, because we do not apply the force to the center but right here. And if you imagine, if you would use this point to lift this rectangle, then pretty much it will rotate as it did here. Alright, and that was about the impulses and forces. There is another one called torque right here. So as you can see, it affects the angular velocity. So it basically make it to rotate. So you can imagine how it is working. You apply a force right here, and it will rotate. Okay, so that was about this one. So let's go to the next topic. And that was about this tutorial actually. So thank you for watching and have a great day. Welcome back to this section. One thing I almost forget is to draw a circle. So let me add a function called add circle and another called draw circle. So we will add and draw a circle, and here, right here in the update function, display function, we just determine which shape do we have, and according to which shape do we have, we either call the draw square or the draw circle function. So let me do that. The add circle function will be very simple and straightforward because it's almost the same as the add rectangle function. So let me go here, and again this will return with the b2 body and add circle. And the add circle will actually waiting for the center point, which is int x, and int y. It will wait the radius, which can be an int and r like radius, and here it can be dynamic or static again, so another boolean, and I just call it din and make it true like dynamic. Right, but the implementation is almost the same as in case of the add rectangle. This first part, wherever we just set the position, set the body definition, and set the body, will be completely same. And here where we set the body type, it will be not a polygon shape, but it will be a circle shape. Circle shape. And if I open up the circle shape header file in the collision shapes and circle shape.h, you can see that it has a M type, which we don't want to modify, it's automatic, M radius, which we want to modify, this is the radius, so let me immediately modify that. So shape.m underscore radius, and this M radius will be the R, and remember we have to convert it to meter, so pixel to meter. Right, and finally we have the MP, which is the position. So mp.set, so shape.m underscore p.set. The set function is basically for B2 vectors, and it set the vector, as you probably have guessed. So just set it to xy. Right, and that was pretty much it. We have a circle, and let's see the next part. Nothing else is changing actually. That was all change we had to do, is to change the B2 polygon shape to circle shape and set its properties. Similarly, you can create an edge shape or what else is here, edge shape and chain shape. That's a connected edge, isn't it? I think so. So you can use chain or edge to make the map, so the actual ground. Right, so we have it, and we'll return with the body. Okay, and let me make a function which draw that out, which is a bit tricky, and I call it draw circle. And it's waiting for the B2 vec2, and it's at the center, and waiting for the radius, which is a float radius. Is there anything else? An angle, so float angle. The angle doesn't really matter unless you have textures on it, because the circle looks the same, doesn't matter how you look at it. But if you color it to different colors, so different vertex to different colors, or you add texture, then it will be obviously seen what is the angle. Right, so to draw a circle, it's a well-known fact right here in GIMP. I will show you that if you have a circle, this is a unit circle, it's meaning that its radius is 1. So this is the coordinate system. So you have a circle, and you have an angle on this circle like this one. Then whatever this angle is basically projected to the x-axis is the cosine of this. So this is the cosine of the angle, and whatever is projected to the y-axis, this is the sine of the angle. This is a well-known fact, but you can easily prove it as well. We will not do such things. So this is the sinus and cosinus. So what can we do is basically get a lot of different angles depending on how perfectly you want to make this circle, and then for each vertex basically draw a rectangle, draw a triangle from the center to this point, and basically that's all you do. And we are going to use triangle fence, which makes it easier because the first vertex, like here, this is the first vertex, and the next two be forming a triangle like this. But if you the third vertex will actually forming a triangle be the last two vertex, but not like triangle strip, but from the center like this. And then the next point again forming another triangle from the center, and so on. We're going to forming triangles from the center to the specific sinus and cosinus vector coordinates, and that will give back our circle if everything goes correctly. Yeah, this is pretty much it. Okay, and here is our circle. Those of you who are using SDL, you basically just want to use little line segments right here instead of using triangles or triangle strips or things like that. Okay, so here I will first set the color, so GL color 3F, so basically doing the same thing as I did in draw square, and then GL push matrix, and we use the GL pop matrix and not screw up our transformation matrix. And here we'll load the identity. Actually, we don't need that. We just translate to the current coordinate, so center.x multiplied by meter to pixels, again to be in pixels, and center.y multiplied by meter to pixels, and then just a 0 because we don't want to move any unit at the z-axis because we are working in 2D. Now we are rotating, so GL rotate F, and let's rotate it by angle times 180 80 divided by m underscore pi to convert it to degrees from radians. Right, and here where the trick will come. So GL begin and GL triangle fan and GL end. So this is what starts out from the center. So first of all we have to do the center point, because that will be the first vertex. So the first vertex is the center point, and the next all vertex is basically the triangles forming to the center point. So this is how it is, and then it will form our circle. So first of all, let's draw the center point. So GL vertex 2F and 0, 0, because we are already in the center point, because we translated to the center point. And then use a for loop to go through all of the angles. So for int, actually make it float. So float I equals 0. We start from 0 degrees, and we'll go while we are less than or equal to 360, and I plus equal to some value. Let me see what these values will be. The higher this value will be, the more precise the circle will be. So let me make a variable for that, and const int, and I don't know, I call it num or whatever, precision. Okay, and I don't know, make it 10. Okay, and the precision will go I plus equal 360 divided by this precision. Okay, so this is, for example, in case of this, every time we go 36 degrees between the last and the current vertex. Anyway, so 10 is a good value because we don't draw that big circle, so I think it should be enough. Alright, so as I said, we use the GL vertex 2F, and we first get the cosine. So cosine of this I, and we should convert this I to actual degrees instead of radians. So I will multiply it by 180 divided by m, actually opposite way, m pi divided by 180. So I have now converted it to radians, actually radians. So I converted the degrees to radians, and now I have to multiply it by the radius, because if we have a unit circle for this, then if I just multiply this point by, I don't know, 2, then I get this point. So basically the radius will be 2, and because it's a unit circle, if you multiply it by 10, then we know that the radius will be exactly 10, because it was 1 before, and 1 times 10 is 10. Okay, so I multiply it by the radius, and actually I have to multiply it by meter to pixel, so multiplied by meter to pixel, because the radius was in meters and we want pixels in this case. Right, this was the first, and the second is actually get the sine, and the sine is actually the I times m pi, and this is divided by 180 multiplied by r, and again multiplied by m to p, like meter to pixels. And we have too many parentheses there. We should put it here. Right, and I'm pretty sure that was it. We will see if it is working or not. And yeah, that was it. Now we have to decide whenever we want to use the draw rectangle or the draw circle function right here in the display. So we go through all of the polygons right here, and we should use an if. So if the TMP we get the shape, first of all, let me just copy that. So TMP get fixture and get shape to get the shape, and in the shape right here I have opened it up. We have a function called get type right here, get type, and it will return an enumeration from this type right here. So it is 0 if it was a circle, it is 1 if it was an edge, 2 if the polygon, 3 if chain, and 4 if type count. I'm not sure what this last, of course, the number of types currently. So there are the types in the current implementation. So let me see. So use the get type, and if this variable is equal to 0, that means it's a circle. So if it is a circle, then we can freely convert it to B2 a circle shape. So I use the TMP get fixture is get shape to get the shape, and now I will convert it to a circle shape instead of a polygon shape. Circle shape, B2 circle shape, that's right. And now that we have a circle shape, we can get the radius and the position of this. So let me just create a variable to make our life easier, b2 circle shape, and this is a pointer. I call it just C. Doesn't really matter, it's just temporarily to make our life easier. We don't have to type this whole line whenever we want to get something, and although it might be quicker, although I guess the compiler will actually optimize that. Okay, so we will use the draw circle function, draw circle, and the draw circle function will wait for the center point, which is C m underscore p. Okay, it's waiting for the radius, which is C and m underscore radius, and this is the 2 parameter which the get circle will wait, if I remember correctly. Draw circle wait, oh no, the angle, of course, the angle. Let me put the angle as well. So C, and actually no, this is tmp get angle, and actually I have just screwed up because we should use the tmp get vert center to get the vert center. This mp is actually not the vert center, but it is the local center, I think so. And actually, if I go here to the add circle, let me just look right here in the add circle, this is at the local, so this mp is actually the local center of the circle, which should be 0, 0. The center of the circle is here in the body definition, not in the circle shape. Okay, now that I have clarified that little mistake of mine, we can get back here and we get the vert center, we get the radius from the circle shape, and we get the angle from the body. Okay, that was it. Else, because we have just 2 body, I don't have to write an else if, just a normal else. I can do whatever I did earlier, so use the draw shape function, draw square function. Right, and I'm pretty sure we are ready for a try. So let me go to my folder and compile the main.cpp, not that one, that's the shadows, in GLSL. That is it. Okay, din was not declared in the scope, 76 and 157. So first of all, let me see here, draw circle was not declared in the scope. Of course, circle like this, the L comes later. Okay, and 76, right here, the din was not declared in the scope because this is not din, this is din. Okay, and now if I run the program, and of course I should do something with this circle. For example, let's add the circle, but first of all delete this pre-solve thing, so it will go through the grunt. So right here, instead of adding a rectangle whenever I press the mouse button, I will add the circle. So add circle, and this again circle. So this waiting for the event.button.x, event.button.y, and radius, I don't know, 15, and then just make it true because it is a dynamic object. And now if I compile it and add circle, right, what did I call it? Of course I circle, I wrote wrong everywhere. Now if I compile it and run it, as you can see, I can add a circle. It seems quite circly, I guess. If you increase the number of vertices in this draw circle, like increase it to 30, then it might be a little bit more circly. Now let's actually draw one vertex of this circle with a different color so we can see it. So for example, so here if the angle, no, not here, here in the for loop, if the I is less than 20, that will be just one vertex. Let's make it 50, so make it 2 vertex. Then GL vertex free, GL color free F, let it make red, as GL color free F, let me make it white so we can see whenever it is rounding on the ground. And of course we should close this for loop as well. Usually I don't forget that. And now if I add it, it seems weird. Of course I did it with, I make it not white but make it black. Now it should be as we expect. So as you can see, it is a circle, and indeed they are rolling on the ground. Okay, that was about it, and thank you for watching and have a great day.